Hey everybody, so in this video we are going to take a look at parallel lines, perpendicular lines, and then some, other kinds of lines that are not parallel and perpendicular, and just talk a little bit about some of the properties that those lines create. So first, we're going to start off with parallel lines. Parallel lines, you might have heard of it before. They are two lines that basically they never cross each other. So like these two lines, they're both perfectly straight. They're never going to cross one another. Another property that it has is that they are always the same distance apart. So no matter where I measure on these lines, it should always be the same distance. Perpendicular lines are lines that cross each other at 90-degree angles or right angles. So for example, these two lines right here, this one is perfectly straight up and down. This one is perfectly straight left and right. So the angle that gets created between them is a right angle, a 90-degree angle, and we usually indicate it using a square. So you might have seen this before in like trigonometry. If you like draw a triangle, usually there's one angle in the corner that has a square in it. That is because those two lines are perpendicular and they create a 90-degree angle. So just a couple other definitions here. If we just kind of go down a little bit, we have complementary and supplementary angles. So complementary are two angles that add up to 90 degrees. So for example, this angle right here, here in this corner, this line here going up and down and this line going left and right add up to, or it creates a 90-degree angle. If we were to draw a line that kind of splits these two up, the two angles that are created from this line that's kind of going in between them should add up to 90 because, you can see here, this is 90, so part of it on top and part of it on the right. When you add those together, you should get 90. So for example, this could be 50 degrees, and this could be 40 degrees. The reason why this could be important is because say we draw something like this, and I don't know, let's create a line that looks like that, and let's say this is 60 degrees, and we want to know what this angle is here. Well, if we know that these are complementary lines because they are perpendicular to each other, we could find this angle here by just doing 90, which is the total, minus 60, which is the angle that we know. So this part here would be 30 degrees. So that's just another little handy thing that we can do with complementary angles. But this one here, the second one, supplementary, this is the one that is going to be more important. And we're going to see why through some examples further on in this lesson. So supplementary angles are just two angles that add up to 180 degrees. And if you look at a protractor, so like this here, you can see here 90 is here in the middle, 0 is here on the bottom, 180 is here on the left. So if we were to create an angle like this, straight up and down, and then left and right, that would be a 90-degree angle, a right angle. A 180-degree angle goes all the way across. So 180 degrees is basically a straight line. So if we were to create a straight line like we have right here, and we were to split it up somehow, so split this up here, let's say this is 40 degrees, this side here would be 180 subtract 40, which equals 140. Same thing if we were to do the calculation here for the 40, if we know that the total is 180, we can do 180 minus 140. That's going to give me 40 degrees. So we're going to be using this property through the next couple of examples. But first, we do have a couple more definitions here at the bottom. Intersecting lines. So these are going to be just two lines that kind of cross each other. So like for example, right here, these lines are not parallel because they do cross each other. They're not perpendicular because there's no 90-degree angle. There's no like straight edge anywhere. It's kind of crooked. Okay, so these are going to be like, let's say 99% of our angles that we're going to look at are just going to be random angles. But we're going to be using especially the supplementary angle property to try to figure out all of the different values for these angles. But first, there are some definitions here, more definitions. When two lines intersect each other, like these two do, there are four angles that are created. So there's angle 1, angle 2, angle 3, angle 4. Adjacent angles are angles that share a side. So for example, 1 and 2 are adjacent because they're beside each other. 1 and 3 are adjacent because they're beside each other. Another example, 3 and 4 are adjacent. 2 and 4 are adjacent. Adjacent angles are angles that are basically beside one another. A vertically opposite angle are the angles that are across from one another. So for example, 1 and 4, those are vertically opposite. 2 and 3, those are vertically opposite. I like using the term kissing angles because it looks like these are like two lines that are kind of kissing each other at that point. That's kind of how I call them. But I guess vertically opposite angles is technically more correct. Then there's just a couple of other properties here. It says adjacent angles are always supplementary. So 1 and 2, because they're on this straight line, these are supplementary and they should add up to 180. 1 and 3, they're on this straight line here, so those will add up to 180. Same with 3 and 4, because they're on this line. 2 and 4 are on this line, so they are going to add up to 180. And it also says vertically opposite angles are always equal. So these ones that are across from each other, that are kind of kissing each other, they are going to be equal. So 1 is going to be equal to 4, 2 is going to be equal to 3. Okay, so we're going to take a look at an example on the next page and see how we can use this. So we have these lines right here. It's telling us that this angle right here is 138 degrees. How are we going to find the missing angles? Well, there is kind of a solution here, but we're going to kind of talk through it. So 1 and the angle across from it are vertically opposite, which means they are going to be equal to each other. So that means angle 1 is also 138 degrees. So we can kind of fill it in here on the right side. Angle 1 is also going to be 138. Then there's a few different ways that we can approach this. We could say that 3 and this angle are supplementary. We could also say 2 and this angle are supplementary because they're both on the same line. Another way that we could think about it, 2 and 3 are also vertically opposite angles. So as long as we can solve for one of them, then the other one should be the same thing. 2 and 3 are going to be equal to each other. So it says right here, angle 3 plus angle 4 is equal to 180. So to find angle 3, we're going to do 180 minus this 138, and we get 42 degrees. So angle 3 is 42 degrees. And then because 2 and 3 are vertically opposite, again, they're kind of across from each other at that point, that means angle 2 also has to be 42 degrees. All right, so take a look at some of the problems, and yeah,